Okay, today we're going to do some applications of conics. Remember, we've done circles, which is what, x minus h squared plus y minus k squared equals r squared. And we did an ellipse, which is x minus h squared over a squared plus y minus k squared over b squared equals 1. A hyperbola is x minus h squared over a squared minus y minus k squared over b squared, or they're flip-flopped. And a parabola is y equals 1 over, let's put the h and k in there, sorry. Y minus k equals 1 over 4p x minus h squared, or x minus h equals 1 over 4p y minus k squared. Okay, now we got all our equations. Boop, boop. You should know them all. All right, in a whispering gallery, a person standing on one focus of the ellipse can whisper and be heard by another person standing at the other end at the other focus, because all sound waves that reach the ceiling from one focus are reflected to the other focus. What they're telling you is, here's the floor, and the ceiling is elliptical. Okay, the Statuary Hall in the United States Capitol is an elliptical room, and Democrats can have a desk right here on the focus. The Republicans have a desk over here on that focus, and if they're over here whispering about a new bill they're trying to pass, because it's a whispering gallery, the sound bounces off the ceiling and lands at the other desk, as long as it's sitting at the focus. And that actually happened. Okay. Anyway, they want me to write the equation for this. And they're telling me that my ellipse is 46 feet wide and 97 feet long. Well, 46 means if I continue this through a tunnel from here to here's 46. So the top is only 23. And 96 is the full length. So half of it from here to here is 48.5. Okay, where are the foci? So what you need to do is write an equation for the ellipse. Well, let's put the center at 0, 0. So you get x squared plus y squared. In the x direction, it goes 48.5 squared. In the y direction, it goes 23 squared equals 1. And remember, the foci, it's because this is adding, it's subtracting, so you subtract 48.5 squared minus 23 squared, and that'll give you c, which is the distance from the center. So what is that? I don't know. So 48.5 squared plus, delete, minus 23 squared, and then take the square root. I get 42.6995. So 42.7 feet from center. Or we could do 48.5 minus that, or it's 5 feet from this end. Okay, so this is 5 feet away. Answers that question. Okay. A very large array in New Mexico consists of 27 radio telescopes. For each parabolic telescope dish. Okay, so you have a telescope dish. It's like your dish on your TV. That's a parabola. Okay. And the receiver is at the focus. When you have a satellite dish and it's receiving sound and light, it goes into the focus. All right. It bounces off the sides and into the focus. All right, so they're telling me the diameter up here is 25, and they're telling me the distance between the vertex and the focus is 0.36 times the diameter. Okay, so here's this. Write an equation for the cross-section of a dish which opens upward, and this vertex is at the origin. So that's 0, 0. If it's opening up, it's an x squared, and it's at the origin, so we don't need the h and a k. And you have 1 over 4p. Remember, p is the distance from the vertex to the focus. So that's 0.36 times the radius, which is 25. So 0.36 times 25 is 9. So my equation is y equals 1 over 4 times 9 is 36, x squared. And then they want to know how deep the dish is. Well, let's see. This point right here, we know x is 25, and we don't know what y is. So if I plug it into this equation, y is equal to 1 over 36 times 25 squared. So 25 squared divided by 36, y is equal to 17.36 meters. Because that's flat across. Good way to do it. You need the ordered pair. All right, next we got a cable on a suspension bridge. Think of the bridge in San Francisco. You know, the bridge is going across the water. There's posts, and then there's stakes up here, and there's cables that suspend and come down and droop like this. Over here there's another one, and it droops down like this. All right, it says the towers supporting the cables are 600 feet apart, so this is 600. And they're 80 feet tall. If the cable touches the road surface midway between the towers, what's the height of the cable at a point 100 feet from the tower? So we're going in this way. All right, so what I'm going to do is make this point right here 0, 0. It's the vertex. This point over here is 300. So this point right here is 300, 80. And it's parabolic, and it's opening up. So we know, again, it's y equals 1 over 4p x squared. If I plug in the values they gave me, I can solve for 4p. So 80 is equal to 1 over 4p times 300 squared. Okay, so 80 over 300 squared equals 1 over 4p. So I'm just going to leave my equation that way. So y is equal to 80 over 300 squared times x squared. And then they want to know the height of the cable 100 feet from the tower. So that's right here. So x is equal to 200. Because it's 300 here, 100 feet from the tower brings you back to here. So you plug in 200. So y is equal to 80 over 300 squared times 200 squared. And let's see what our math tells us. 200 squared times 80 divided by 300 squared tells me it's 35.5 feet high. So at this point, that's 35 feet high. This one's at 80. Okay? You got to know your equations. All right. The last thing we're going to do is solve a system of conics. All right, well, I looked at this and I said, well, this is a circle with a center at 5, 0. So 1, 2, 3, 4, 5, here he is. And I can draw my circle. Let's see if I can do this. Oh, I did it. Good. It's close. Okay, so there's my circle. This is a parabola that opens to the right. It starts at the origin, and it goes like this. And it goes like this. So I'm intersecting at this point, and this point, and I need to know what those are. Well, I'll look at my two equations. If I take this one and solve for x squared, I get 8x is equal to y squared. And then I'm going to come in here and replace y squared. So I have x minus 5 squared plus 8x equals 25. You have to FOIL that. You get x squared minus 10x plus 25 plus 8x equals 25. It's a quadratic. You always set it equal to 0. So you get x squared. You have minus 10 plus 8, so that's negative 2x. Subtract 25, it goes away. You pull out an x, and you get x minus 2. So my x values are x equals 0 and x equals 2. Well, I go back and plug that in here. So 0 equals 1/8 y squared. You multiply by 8, you still get 0. So it goes through 0, 0. That makes sense. Then you plug in 2. You multiply by 8 and you get 16 equals y squared. You take the square root of 16. You need the plus or minus, so you have y is equal to plus or minus 4. So 0, 0 is this point. This one is 2, negative 4. And this point is 2, positive 4. So those are all the intersections. And that's what they asked you to do, is solve the system of equations. What xy coordinates will make both equations true. Okay, that's all there is. Practice, 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 y'all. Next class we review, and then we take a quiz.